You have the floor.
Great, thanks so much. So we're going to run through a bit of background, introduction to what concepts are, concept dynamics, how we sort of approached formalizing them at Palantir, what the glossary ended up looking like. But to start, the three of us are a bit of an unlikely research group. I'm not a professional academic. I work in the software industry. Taylor's one of my best friends from college who I've worked together for years with, and Daniel's a professor at MIT. So, you know, how did we meet? How did this all come together? The beginning, and I think it's a pretty big pivot for Dr. Jackson, is publishing this paper towards a theory of conceptual design for software in about 2015. I came across this paper, you know, on the internet. It was a PDF. Thank you for open access. And started reading it, was really inspired, started giving internal talks about this sort of style of software development. Dr. Jackson published a book, The Essence of Software, in 2021. I read it, thought a lot about it, and then starting in 2022, we started collaborating on sort of what would it look like to apply some of these theoretical ideas in practice, sort of at scale, at a large software development organization. So, what are concepts? What is conceptual integrity? I think of this as sort of this almost dismal reality, which is, you know, as software developers, as people building systems, we have this goal of creating systems that have integrity, where, you know, all the way down the system, there's sort of this fractal cohesion to the system, so that when you're using it, you can't really tell who built it. You can't really tell that it was built by many people. It really feels like a cohesive whole. And that's really, you know, if you think about the Platonic ideal of a large-scale software system, that's sort of the ideal. And then you have this tragic element, which, you know, is often known by the concept of Conway's law after Melvin Conway, which is that as organizations that build software scale, it becomes functionally impossible to achieve this conceptual integrity. And so this is a sort of diagram from his paper, his essay on this topic in the 70s, and this is sort of a tongue-in-cheek, joking version from 2011. So showing 6 big tech companies and sort of how their organizational structure is shaped. And if you look at these structures, they tend to resemble the products, right? They tend to resemble the software systems that these people are building. The joking one is Oracle with the legal department in the bottom left. And so I've been at Palantir for a little over 11 years. In that time, the company's grown and grown and grown. And at this point, we're really building a very large software system. So just to contextualize that for some of you, it's about 1,000 developers, maybe 1,300 people contributing in different capacities to a code base across close to 2,000 Git repos, ranging from, you know, 10,000, 20,000 lines of code up to 9 million lines of code. And, you know, let's say every 3 months, the diff is about 54 million lines of code, right? So this is not the biggest software organization in the world, but certainly in the happy middle of large software organizations trying to collaborate at scale. And what we were finding, and this is a finding that I think if you talk to people at other large software companies, that they will agree with you, is that over time, the organizational structure of the company was starting to bleed into the product. So this idea of having software that really felt cohesive and felt integrated was starting to resemble the org structure. And so really the goal we had with approaching, you know, concepts as a first-class development primitive was, you know, could we have an organization structure that was quite decentralized, sort of more like the Facebook graph on the left, but with a software product, a set of systems that looked more like sort of the canonical Apple highly integrated system, sort of on the right, but without, you know, Steve Jobs in the middle. And so maybe it's worth stepping back a little bit. Concepts are, you know, vague, ephemeral. They're a little bit hard to pin down. But in his 2015 essay, Dr. Jackson sort of defined them very, very objectively. And so the idea of concepts in the paper, and this is sort of the first introduction to sentences to the paper, is that they are, you know, teleological instruments. They have a purpose, they are created, they are objective, and they're designed by the designer of the system and then learned by the user of a system, right? And so if you ever, you know, report the most frustrating class of bugs about software, there's sort of those bugs where you said, hey, you know, it doesn't make sense that when I do X, Y, Z, you know, this happens. And the designer says, no, that's not a bug, that's expected. And it's expected by the designer, but not by the user. And so there's this sense in which concepts become almost a pedagogical construct. Like the software is designed to teach the user about a series of concepts that are useful within the domain. Why do they matter at Palantir? Over the past 20 years, we've sort of moved from building a really domain-specific intelligence product to building a general platform that's centered around the idea of an ontology. And so if any of you have done work in the semantic web or sort of ontology modeling, rectification between different system models, there is this sort of fundamental thing, which is that you have external systems, you have an ontology model, you build applications on top of that ontology model, you store data in that ontology model, or you federate. And so fundamentally, the task of building such a system is really mapping other people's concepts, right? Concepts from the world, ideas from the world that other systems express into a cohesive ontology, right? An ontology in which all of the concepts of the subsuming systems are expressed. And so you can sort of think about this with an operating system analogy where a programmer interacts with the sort of concept of a printer, but then there's some abstraction where a printer driver is sort of translating the physical printer into that conceptual printer for the programmer to interoperate with. This is sort of taking that and doing it with virtual systems as opposed to physical systems, but that translation model really is central to what we do, and part of why concepts became such a sort of endemic part of our development process. So what makes a good concept? This is lifted right from some of the earlier work. It has a motivation. It's not redundant, right? You see this all the time where you have two concepts that end up being sort of effectively the same. They're not overloaded. You have these concepts that really do one thing as opposed to many things. That lets you combine them and compose them together. And when you think about great software that you use, it tends to have this compositional element, right? Learning the lower level primitives allows you to sort of do higher level things. And this is maybe manifested most strongly in design patterns versus language features within programming languages, where you can take lower level language features and sort of assemble them in higher level design patterns as a user. That requires mastery, that requires a lot of skill, but it is sort of doable. And then uniformity, which is variants of the same concept should have similar behaviors, right? When you have a comment box or a chat box, maybe the bolding and the rich text formatting should feel similar because they're sort of similar concepts. And these are two sort of dependency diagrams that Dr. Jackson put together of a basic word processor and a social network, right? So the concept graphs of the core things you have to know as a user to use this software. And that's really the core of the paper and then the later book. But as someone working in industry, I was actually very interested in sort of what I start calling concept dynamics, right? And so this is, if you think about analyzing a chess board versus analyzing the gameplay of chess, the big difference is movement. It's the fact that these pieces move, these concepts change, and concepts do evolve over time, right? They change and evolve. If you've used software at all for the past 20 years, it has changed a lot. Some of the concepts have stayed similar, some have stayed different. I think about this as sort of, hemoglobin has stayed pretty similar in the genetics of organisms, but higher level abstractions sort of change more rapidly. And, this isn't quite the right reference frame because they're actually evolved by teams, right? And they're evolved by teams to sort of win in this quite Darwinian market economy. And so as an example, you can think of iOS 7. So iOS 7 introduced the flashlight feature to iOS. I think this is often the simplest example. There used to be a concept in iOS, which was the flash feature, right? It was a camera photography-centric feature. Some clever people, maybe 50, 60 people, teams of people, built flashlight apps in the App Store. And there was a period before iOS 7 where flashlight apps were actually a pretty big revenue stream for a number of companies. Apple released this feature. I took a screenshot of these companies. It's dead. Like, these have real economic consequences because when a platform absorbs concepts that are your differentiator, you have no more business. And so this is sort of what I would consider, an external threat or a homicide situation, right? Where someone adopted your concept and now you're dead. But the other situation that's sort of more interesting perhaps, and in business theory, we sometimes say that businesses die because of suicide, not homicide. These things can be self-inflicted. And so if you read through some of these examples, there's been a lot of critique of Google, for example, for releasing, dozens of the same product. And they don't make sense, they don't really connect together, they all have these overlapping ideas, yet they feel like they're from a bunch of different companies. And because they are from one company, there's an illusion that maybe they should be connected. This was probably taken to the extreme in the mid-2010s Microsoft, right? Where Microsoft in the middle of 2010 was often pitched as the Office team, the Windows team, the cloud team, all sort of fighting each other, operating independently, really sort of operating more like, a warlording organization that was fighting internally for the spoils. And again, to reiterate, these have consequences. When you look at, the reorgs and changes at Microsoft, you take, a pretty stagnant stock to a stock that, since 2014 is really, 100x in price. So, what I would say is conceptual integrity drives product quality drives economic returns, and so this really, really does matter. What we started doing at Palantir, let's say in 2022, the starting point we had was individual concepts existed, but the idea of a concept did not. And so what I mean by that is concepts were effervescent in the language. When you talk to developers, designers, product managers, they would use the same words. Like if you sort of analyze the natural language, there would be terms and tokens within that natural language, which did correspond very strongly to software components and concepts. But they didn't exist formally. We didn't have a word for a concept. We sort of sometimes called them primitives, sometimes called them like low-level building blocks, but we didn't have a word for them. And so Taylor and I, have been going back for years and years. We hike a lot together. We were on a hiking trip, and we were talking about this idea, and he said, let's come back, let's build something, let's try to make these things formal, add them into the development process. And in doing so, we were, really inspired by two books, The Essence of Software by Dr. Jackson, and then A Pattern Language. And the resulting glossary that we developed and designed and have been building into the development lifecycle, blends sort of ideas from both of these books together. And so what that ends up looking like is sort of a glossary, A to Z. This is me. I own the acceleration node concept of sort of components, concepts, and concept diagrams. And so for people who've worked at large software organizations or even small software organizations, you probably have a good sense of what components are. Components are much less abstract. They were formalized at Palantir much earlier than concepts, and they really correspond, again, very naturally to team structures. Teams tend to own pieces of code. Components tend to be sort of these deployable units of code, whether it's an application or a back-end capability, a collection of microservices, right? These are pretty natural things that we're used to sort of working with in large-scale software engineering. Concept diagrams, they're just pictures, right? This is really taken from a pattern language with the idea that concepts are really best expressed visually as opposed to with words. So these are a couple of concept diagrams for the concept of a data bank, which is, a way to take multiple systems, merge them into sort of a unified knowledge graph, re-index that knowledge graph into different, search and indexing systems. This is sort of a picture of that. This is a picture of some concepts that relate to templating and stenciling. Basically, what is the difference between sort of a document template and a form? Is there something, we've been calling it a stencil that sort of blends elements of a form and a document template together to allow you to have more consistent structured reporting with the same ergonomics of writing a document. And some of these concept diagrams can be a little bit more whimsical, right? So we had this idea of snapshotting and clipping pieces of visual state, and we were struggling with, different ideas of temporal ordering and when the system's sort of internal clocks were changing versus when the world is changing versus when the world updates enter the system. And so this is a visual diagram of just, a whimsical example of an astronaut with a telescope taking pictures of things in the world. But again, these are the three sort of constituent parts of this glossary. You have concepts, components, and diagrams. So diving into the glossary a little bit more, this is roughly what it looks like when you search for something. So this is a search for tag. It shows the alias for this and the owner, right? So we really were trying to blend the system documentation with the organizational design quite a lot. Aliases, again, we'll get back to that a little bit later, are probably the most important part of the glossary. They allow you to dereference things, which again, in colloquial natural language, never really happens. You have people who call labels tags and tags labels. It's not clear which is canonical. And then each concept corresponds to sort of an object view, right? So the concept of security marking, this shows the evolution of diagrams that people have built over many, many years, going back, let's say to 2016, 2018, 2018, 2022. These are all just different diagrams of these concepts as they evolved. And this is all being pulled from internal knowledge management systems. It's really a new entity-centric way of organizing those systems to show the evolution and design and collaboration on the concepts over time. So aliases, what are aliases? These came up as we were designing the concept glossary. They were actually sort of a fundamental part of our ontology language. And we realized, similar to how we use them for de-aliasing class types in our ontology, it was also very, very important because these concepts were actually instances of the concept class within our glossary to allow you to reference the same concept by many different terms. So to use a concrete example, this is searching for tag. There are actually sort of a few different things in the system, items in the glossary that might be thought of as tags by end users. So releases get tagged via like a git tagging process. References and tags are actually quite different for us. References are embedded in the document content. Tags are sort of a layer on top that are user curated. There's also some overlap between what a lot of systems would call tags and what we call labels. Again, because we sort of use tags as more of an entity extraction referencing tool, a lot of other systems use them as a label on a document. And so, again, dereferencing the idea of both what our internal vernacular is and then how that corresponds to external vernacular or other products. A classic example would be a chat room and a channel. Whether or not you choose to call it a chat room or a channel, there are other products that use two different terms for that same concept, and so you want to be able to dereference those within the glossary, right, and get to the canonical version. So for us, tag is the canonical version of tag, but many people would use that word to refer to other concepts. The glossary is still evolving. It has about, a little bit under 300 users at this point compared to about 550 users of the component type. To baseline, the usage of the employee type is about 2,300 internally. So, we're about, let's say, 10% penetration of the total, and then probably about 40-50% penetration of the component type. There are plenty of things to talk through in terms of how this integrates with other internal processes, especially around documentation. And I think that's where we see the strongest likelihood of building a flywheel where these things are both internal and external representations. And again, that ties to just an observation we've had over and over in the history of our company, which is that knowledge management that's not tied to an operational workflow is basically dead on arrival. It's always decaying and it's not going to compound naturally. So if you want to do this, if you want to adopt something like this for your organization, what are the things that you would do to create a glossary? One, inventory the concepts. I wouldn't over-engineer this. We just grabbed a couple beers and chugged through the concepts for a few days and got to pretty good penetration. Two, focus on the need. Don't think about them as architectural components. I think this is sometimes the hardest thing as a designer, which is these are meant to be user-facing ideas. And so, again, the line between user and developer does blur when you're building developer tools especially, but there really is a difference between sort of the internal implementation details and the thing, a developer needs to understand in order to use your system. Record the relationships. We found this most helpful to do in diagrams, so concepts that co-occurred in diagrams tended to be related, and so we use diagrams as sort of the edges in our concept graph between concepts and components. Resist perfectionism. Correctness is not going to be defined in a formal way. In general, you just want to have breadth of the concept so that the glossary starts becoming a living document that can start acting a bit as more of a wiki and get a lot of adoption from a lot of different people. And so you just want to have breadth and don't need to worry as much about depth. Probably the most important thing about concepts, and again, it's the hardest problem in computer science for a reason. Naming is very hard. It feels like bike shedding. but it's not. And the reality is good names really convey a lot of context. And especially when you're thinking about a product that's going to be internationalized and translated across many languages, picking great English names is going to be what lets a translator who's an expert in another language really find a word in that language that maps onto it. And so, one of the things, even as we think about internationalizing our software, is the concept terms probably need to be translated differently than other text within the system, right? We really do want someone with a native level fluency translating these terms in a way where, descriptions, paragraphs, other text might be able to be more amenable to a machine translation system. Focus on value, be pragmatic, teach people about concepts, do a class, have a recorded lecture, give them the paper, have them read it, and then integrate them into planning. I think in a lot of cases, concepts exist in the present day, but the most exciting new features tend to be new ideas that you're putting into the platform, sometimes that don't exist in any other piece of software ever. So you want to put them into planning, you want to be able to explicitly say, hey, this feature is introducing a new concept, and that means that actually many teams are going to have to implement it. You're going to have an idea for how you get that consensus, and you're going to have to differentiate features like that from features that are sort of internal to a single team. If you're interested in further reading, again, these are sort of not necessarily the most pure academic things, but I think these are four papers, 4 books that really have inspired a lot of our thinking on this topic. Paul Romer, I think, is probably one of the most interesting economists right now on just how innovation happens, how the economy actually grows, thinking about new ideas as sort of a core economic driver of the economy. James Scott is sort of a very famous decentralized thinker, pushing away from authoritarian tendencies. I think, programming and building these sort of complex systems pushes you often towards a centralized mindset. Scott is a very, very big advocate of decentralization. Sinofsky was in charge of large groups of engineers at Windows for 20, 30 years, wrote a really phenomenal book about how to sort of maintain conceptual integrity by what he calls strategic integrity, which is sort of the integration of planning and design. And then Joel Spolsky, I think especially the early Joel on software posts give a great overview of just big design up front, how to do actual design-centric software, as opposed to, what I think has become more of a common sort of agile pattern. Don't think too far ahead, just sort of start coding as soon as you can. So to recap, I think this is a really interesting way to start organizing software teams. We're really excited about, the potential, and happy to talk to anyone else who might be interested in these ideas.
So, great talk. Actually, during the talk, I accidentally turned on the flashlight on my phone. How this happened, I don't know. I'm using it wrong, I think. We have time for some questions.
Thank you very much for your presentation. How do you think that the collection of glossaries should be structured? Should there be a glossary per team, per product, per organization? Should there be one glossary worldwide?
Yeah, it's a great question. I don't think it should be lined up with the organizational structure. I think that's sort of one of the key things the glossary doesn't do. That being said, if you saw in some of the slides, we actually have a superstructure in the glossary itself. We call it aspects here, sort of inspired by aspect-oriented programming, but topics, or in the paper we call these concept clusters. I think having clusters and driving ownership via clusters is sort of the way I've been thinking about this, where an individual cluster would likely have an owner, but that owner would sort of be matrixed with a bunch of teams. And so I think a lot about concepts as a bit of a matrixed structure. You now have things that are physical within your system, or at least, very tactile, that you can own and feel ownership of. And so I think of, if you think about like concepts on the y-axis and components on the x-axis, you sort of end up having your people spread in the middle with perhaps a lot, stronger biases towards concepts or components, depending on role and position and tenure and, responsibility. But I think of them as sort of disjoint from components.
Wondering about the names. Have you found a name for something that you want to rename, but people got used to it?
Yeah, renaming is really, really important and really, really hard. We've done this quite a bit. I think it tends to be more the case that it's not I don't find it often that there's a bad name, right? Like the people naming things have thought about it, you know, when they were making it at the time, it was assigned with a purpose. I think going back to the sort of redundancy and overloading things in terms of good concepts, it tends to be the case that what happens is a concept that exists is starting to be used for purposes that it wasn't intended to be used for by the designers. And so I think it's more common to need to sort of mitote concepts into multiple concepts that are sort of closely related. You know, we have concepts of branching and pull requests, which, you know, are very similar, but over time we actually had to differentiate them quite a bit in terms of what is a branch and what is a proposal to make a change and a merge. That's an example of sort of mitosis. And then the other version is sort of aligning concepts across teams. And that's sort of where you have multiple names, multiple things. Sometimes people actually name concepts differently, sort of almost in reaction. Like I think of this almost like in a Hegelian sense, where you have like a thesis and then an antithesis, and then you get to the synthesis, where there's a lot of creativity in that process. But you know, even just choosing to call something a sandbox instead of a branch is actually a choice to say, hey, I'm trying to make a new concept. Like I don't like things about the branch concept, and so I'm choosing a new name. I'm like putting my flag down over here, and then I think bringing that back into the fold. It tends to be the style of synthesis and synthetic development that I do a lot of. But yeah, I think it's less that you rename, it's more that you sort of mitote or reabsorb.
Thanks for the, does it work? Yeah. Thanks for the great talk. As far as I know, Daniel Jackson also came up with this tool, I think it's called Alloy, to formalize I think those like kind of concepts and then to be able to actually check the integrity of the concepts. Have you actually experimented with this tool, and what are your thoughts on it?
We haven't experimented with Alloy. I think it's great. I think trying to, you know, again, we're trying to formalize things that are currently very informal, and I think that was probably a level of formality that we weren't ready for at our organization. Within our own product, I think I showed you this is what we call an object view. So again, this is an instance of a concept. But you know, within our ontology, you might have employees, GitHub repositories, right? Like your ontology is also going to have classes, which we call object types, that are essentially concepts within your domain. You can sort of think of concepts as our system ontology and then a domain ontology together with that. And within the system, we do have sort of repeated code modules that are used consistently to represent concepts, iconography. And so I think I'm personally very inspired by trying to get towards more of a component-centric world where these concepts actually are reified into source code and used to sort of auto-generate pieces of source. But we definitely haven't done that yet.
Thank you for the talk. It's really, really good. So I see this very much as a developer, designer-centric concepts that get then driven into the software implementation, and maybe a complementary idea is something like domain-driven design that is coming from the user space. How do you see these two potentially working together? I could see how they could very easily clash. How do you reconcile that?
Yeah, we have a big section in the paper about sort of domain-driven design versus concept design. I think there are a few different aspects of this. I think it's really, really interesting. We think of concepts as being within the domain of the developer of the software. And so, you know, especially in building platform-style systems that are intended to be sort of applied into a domain, I think about this as like domain-driven design takes Java as a fixed frame of reference. The concepts included in Java are not sort of within the domain of domain-driven design. It's users of Java who are then designing sort of programs in Java. But I think of software concepts as being more like the primitives of Java. So it's more like language features that you're providing to developers. Again, that does get fuzzy, right? Because as you develop software with people, your domain starts to become software, and it does become quite meta, which is why I think the level of formalism could be helpful. But we do approach domain-driven design pretty aggressively in the paper. It's been a big inspiration for our ontology system itself, and especially sort of code-generating clients and programming abstractions on top of the ontology. But yeah, I think the second piece I'll say is we also think of concepts as a pedagogical tool. So Taylor has started a company. His job is to train people on Foundry. And so he thinks about concepts really sort of in terms of a curriculum and in terms of sort of how do you learn a complex piece of software. I think that's also a place where they're a little bit different from domain-driven design, which is much more taking things that people within the domain know and reifying them into software. This is sort of taking things within the software and teaching them to people within the domain.
Okay, any questions we still have, let's do them during lunch, because we wouldn't dare stand between you and your lunch. So let's thank the speaker again.